Let's talk about using C++ in the Godot game engine. All right, so in the past, I have been a little reluctant to take a look at C++ with the Godot game engine. It's been a while since I've said it. I don't even know if I say Godot or Godot anymore. But anytime I've looked at it, it's either been extremely confusing instructions, at least for me, very unclear, or I find a video that seems to explain it well, and then it turns out, at least from my understanding, that we're using GD extension the entire time. That means any change that you want to make, you then have to go back and completely rebuild the extension, and then go back into the engine and run it and test. And if it's not right, go back, make whatever changes, completely rebuild the extension, and repeat. I don't like that. I find that to be extremely tedious. I don't know why. I guess if a performance is that important to you or to your project, maybe you'd be willing to put up with that. I, however, am not. So what we're going to be using here to use C++ is the Jenova framework. And what this allows us to do is to write C++ headers and C++ scripts from within the engine itself. We don't need to be constantly rebuilding the extension for every tiny change. Now, there's a small rebuild, but that time doesn't take, or takes as long or less than it does for C#. So it's still not that long. Only, 2 seconds, 3 seconds at the end of the day. All right, so I'm going to go ahead and close this. Let's close Visual Studio there. And if I go back, if you want to find it, you can just go ahead and type in Godot Jenova, and you should find the GitHub as the first result. Go ahead and click that. That'll bring you here. And if we scroll down, we can click on documentation. That'll take us to the website to get us going. And we see here it is. And what it's going to do is allow us to write C++. If I hit start now, should see that in here, right? Yes, however, the way designed Jenova makes C++ very easy to use and fun, which is great. You can easily convert any GD script to C++. Again, yeah, that's also fantastic. If you want to go through and you want to read all this, you can. They do have, I believe it's on this page. Maybe it's not this page. Apparently it's not. Maybe it's under miscellaneous. I have the benchmarks. So if you want to come in, you can take a look and you can see some of the charts here. So you can see some of the performance differences here. So we see with spawn and delete, GD script was faster than C#, right? And almost on par with the C++ in this aspect, but C++ of course is destroying it like everything else. There's the final number. So if benchmarks that is important to you, and there it is, you can take a look at that. But what we're interested in here is we're going to introduction, and first thing we need to do is we need to set this up. So now that we have this page open, I'm going to go into the Godot engine. I'm going to hit create. I'm going to go to my YouTube folder, and now we're just going to give it a name. I'm going to call this CPP YouTube. All right, there we go. We'll call it that. Renderer doesn't matter too much. I'm just going to leave it on 4+ because why not, right? Git, yeah, that's all fine. I'll hit create. Give that a moment to create itself. Create itself a new project. And in the meantime, oh, it went ahead and it's already open. Fantastic. So I'll just shrink that down a bit here. All right, that'll take it over. Now over on the website, to get ourselves started, we can see you can see a bunch of information here for it. What we want is getting started, And if we just scroll down, we can see credit Jenova runtime has been ported to Mac OS. I have no idea how to set that up. And as for Linux, that claims their support, again, I'm not sure how to do that. So I don't have a Linux system. But what we are looking for is we have the automatic system, which we're going to use. But if you prefer the manual system, you have the manual set up here for Mac, Linux, and Windows. So I guess for Linux and Mac, you have to do it manually. For Windows, we're going to go to automatic, and we're just going to click the hyperlink that says here. And that's going to give you a download. Let me just open this. Put that inside. Open that up. So I can bring it over here. All right. So you're going to have a Jenova installer file here, an exe that we get from the download. You go ahead and, of course, double click it to run it. There's a few things that we need to do here. And by few, I mean almost nothing. So the first thing is the installation path. This is going to be the path into your project. So you're going to go ahead and hit browse and locate the project that you just created. All right, I've selected it from the browse, and you can look at your options that you have here. But of course, I'm just going to stick it to Microsoft Visual C++. Right, and now just hit install Jenova framework, and now we just wait. Give it a moment while it does its thing. It's going to fetch, install, download, whatever it needs to do. Validating admin privileges, operating system, project, downloading latest build package, fantastic. Validating installation path, cloning package, and verifying package. And we're almost done. Installing the runtime files. This will give us 8 out of 10. That gives us 2 more here, cleaning up. And finally, finalizing. Makes sense. All right, now after we're done, we can go ahead and hit finish. And if we open up our project, you're going to see it's going to freeze for a second and close on you. That's fine. We needed to reboot the project anyway, so just open that back up. And give that its second. Right, so now that you have your project open back up, after running through the installer, you're going to notice Jenova up here in the top corner. We're going to go ahead and open that, go to Tools, go to Package Manager, and you're going to need a compiler and a Godot kit. Now for compiler, I'm going with Microsoft Visual C++. Just hit the install package, give that a few seconds. And once it's done, you can come over to a kit and you can grab one of these. If you want to try 4.5.3, you can. For myself, I had some API errors, so I don't know if that's specifically related to or specifically for Godot 4.5, because this does support 4.2 up to 4.5 right now. But for me, 4.3.08 works best, so that's the one I have installed here. And once you've got a compiler and a kit, installed, you can go ahead and go to project and reload your current project, or close and reopen it, and you should be fine. You should be brought back here. And what we're going to do is we're going to create a small little GUI 2D game. It's going to be very simple. We're just going to click a button and update a label on screen. And by doing this, I'm going to show you how to do variables. You're going to be connecting a signal. You're going to be getting nodes. Of course, you're going to be modifying properties. And of course, the first thing I'm going to show you how to output out to the console. Okay, so I've already got myself a scene here. I've got a 2D scene. I just named it main. I have a canvas layer for my GUI, for my user interface. And on there, I just have a button and a label. And they just have some random text in there and some sized up font. So you can hopefully see it once we change it. Right, so I'm going to go to my main. I'll hit script, and you'll see in the language dropdown we now have C++ script and C++ header. So you can go ahead and select that. Obviously, I'm inheriting from a node 2D because that's what my main node is. And I'll hit load. And this is the script that we have. So by default, you're going to notice a lot of things here. So we have a lot of includes up here. And this is just including a lot of our like header files that C++ is going to use. Obviously, we need some of this for just our basic functionality to do things here. And then we have our namespaces, of course, and this is where our script actually begins. So our code begins in this section here, and it ends above the script end block. Right. So we have on awake, which is the replacement for enter tree, on destroy, which is the replacement for exit tree, on ready is the replacement for ready, on process is the replacement for process. There was also an on physics process, which is a replacement for, as you would imagine, the physics process. And there is on input, which is the replacement for input. So what we're going to use here is we're going to go to the on ready, and we're going to do output directly to our console here. So in GD script, of course, you would do print like that, all lowercase. In C#, we're doing gd.print with a capital. But here with C++, lucky enough, Jenova has actually given us a shortcut here to just type in output, open close parentheses, end that line with a semicolon, because it is one of those languages just like C++. And we can put in whatever string we want here, and the classic, of course, is hello world. So we can save that. We can go to Jenova, hit rebuild solution, or if you have not yet, hit build solution now that you have a C++ script in your project. And you'll wait, you should get some text on here. Everything should be good, no errors. And if we hit run, see, once it starts up, we have hello world printed out to our console here. And I say shortcut because if we were doing this with the GD extensions to get as raw C++ as possible here, this is what we would have to write: std : c out, double arrow, our string that we want to print, double arrow, std : end L for end line, and our semicolon on the end. But since we're using Jenova, we do have some conveniences like this where we can just type in print. Although, or sorry, not print, output. But of course, if we're in with C++ 23, of course you can change that because they're actually just getting a print line like so, where they would be able to do hello world. So it's not really all that different. All right, so for us, so if we want to output to the console or we want to print, we can just type in output. It's as simple as that for us. All right, so outputting, very simple. Now, what if we wanted to take a look at, it's going to minimize that, get that out of my way. Let's start taking a look at how to do some of these variables, right? That way we can modify them out here. Easy enough for us, right? So what we need to do is in here, and I'll go ahead and point out, okay, first of all, we have to be below JavaScript or Jenova script begin, remember, because that's the top of our script. If you are using standard C++, so if you're using GD extensions here, you would use simply for creating, let's go with an int, right? You just do int, let's say run speed, right? And 200, right? You would just do something like that. For us here, what we do here is we do Jenova property, and you'll see that change colors with our keyword. Jenova property, and a few things that we put in here. The first thing is going to be the type, just like before, int. Then we have the name. We had run speed. And we have the default value, and by default, that's all we have to put in. So I'm just going to hit save, go to Jenova, rebuild, and there is a shortcut key. So if you do like hotkeys, you do have one there. I'll run that. We don't really have to run that, so I don't know why I clicked that. I'll just click back onto my script, and we can see it outputted here to the inspector. I don't know why that was hard to think of. Likewise, if we wanted a float, when we're on this level, let's make that running. This is going to be, instead of a float, we're actually going to use what's called a double. Right, so it's going to be 20.0. Jenova rebuild real quick, and we'll see that update. Just click off and back onto our node, and there we go. So we have one for our integers and one for our floats. Now we do have access to all these different things that we want to put. So for example, if we wanted to do a string, I'll go ahead and just get us started here up to what we already know. So we have Jenova property, string, calling this variable a label text, default value is an empty string. And then after that, we have access to some of these modifiers like usage, hint strings, as well as things like groups. And what group is going to give us, if you're familiar with exported groups, just do group colon, pass in a string. And this string is going to be, let's say, label stuff. Right, don't forget to close that parentheses. And I'm going to end it with a semicolon just to keep up with the rest of the code, right? So go to Jenova, rebuild. And if we take a look at the inspector now, we can see we have a group where this now exists. So you want to do something like export groups, that's how you're going to do it. And if you just wanted to do full sections like that, right, or we have one drop down, then that drops down to another group. As you can see here, we just use a slash in between each group name. So there you go with that. And now if you want to do something like an enum, right, so something that's maybe going to have a drop down for a bunch of different options, this is very similar. Go. So we have property. Of course, it's an int because things like enums is represented by numbers. Dummy state, the name of my variable. Sorry. Default value is going to be 0. Now this is where we go into the hint, and we hint to the editor that this is a enum property. And then we use hint string to pass in our values. So idle, walk, and run. Now when we save that and we do a quick rebuild, you can see we now have the drop down with all of our options. All right. And if you don't know what some of these hints are, you can just take a look at, even just in GDScript, just by searching help, looking at the export section. And you can see things like property hint, color no alpha, property usage, script variable, which we do have a usage ability to modify there. So if we didn't want it to be exported, you could just tweak the usage there. As you can see, you can get some information out here to help you go. And you just got to know how to factor it in this case, which hint string colon whatever it is, hint colon, and then whatever the hint that you're passing in there. All right, so how can we use some of this? Well, let's go ahead and print out our run speed. Take a look at how to do that into our hello world. So we'll do hello world, and we'll do our /t to give us a tab in between. And what we're going to do is we're going to do a %i for integer. So that's what we want to put in here. And we're just going to do run speed rebuild. And we should see 200 get printed out to us. Hello world 200. And unless I got it wrong, my mistake. There it is. I forgot a comma there. Save that script. Quick rebuild. hit run. There we go. Hello world, 200. And since this is exported, we could change this to whatever we want. So let's say 550. Save, make sure we're not running. Temporary rebuild. Hit that run. Hello world. We're still getting 200 there. There we go. I just got a little too excited in the and playing the scene, I guess. But there we go. So we see 550 is being printed out and relayed for us. Great. Now, what if we had our running speed, right? That is a double, right? An integer, not an integer. So instead of run speed, of course, we have running speed, but instead of we put in LF, %LF. And again, rebuild that solution. We should see 200.0 get printed out. And there it is, 200.00000, because that's just how far a double goes, right? And this will work for any of our situations. So we can do this with our int. So if we want to do our dummy state, right? Again, that is an int, so we could just do an I and print out our dummy that I'm not remembering. Dummy state. Rebuild, give that a second, run this, and we got 2 printed out to us. And if we take a look, idle is 0, walk is 1, run is 2, run is selected, and that is correct. All right, so hopefully that shows you how we can output to the console, as well as take our variables and insert them into the strings here for us. All right, so now let's take a look at self, because what we can't do is we can't do something. Let's say self dot let's say name, for example. And if we were trying to build that, we should come up with an error. Yes. So undeclared identifier, self, it doesn't know what that is. And we're missing a semicolon. All right, so we do that, rebuild, that should fix one of those errors. Okay, so but we still don't know what self is. Okay, maybe it's like C#. Maybe we try this. No, this can only be referenced inside non-static member functions or non-static data member initializers. So we can't use this here. So how the heck do we get our self if we want to do something like get our name? Well, we're going to do auto. We're going to call it self. And it's going to be equal to open parentheses node 2D, because that's what this is for me. We'll put an asterisk here because we are the caller, and we'll do instance, right? So that we're saying that our instance is a node 2D, and we're actually going to use this arrow to point to our self variable. So we're going to say this node 2D instance is our is going to be self. Now, the problem is, if we try to run this, right, let's go ahead, rebuild it, and we're going to run into the issue, node2d undeclared identifier. It doesn't know what that is. It's also telling us about a syntax error. It's trying to tell us about our parentheses. Now we're missing semicolons and curly braces. But what's actually missing is, since we're using node2d, this script doesn't know about node2ds. So since we want to access this, what we actually need to do is we need to add a new include up here at the top. So include, and we're going to be including Godot / classes / and then whatever it is that we want to use. In our case, there's a node2d.hpp. Right, and if we add that, that's all we've done. It says added that include and saved. Do a rebuild. And let's take a look at what we're missing. We are missing our semicolon. Yes. So I'll put that in, hit rebuild. and we take a look, we should have no more errors now. If we run this, well, nothing's going to happen because we haven't done anything with it. But now we have self and we can do things with it. So one of the things that we can do is we can get our name. And to do this, this actually going to be self. We're going to point out. Now, we're use this error when we're dealing with pointers and use dot like you would in like C# or GD script when we're dealing with an object itself. In our case, self is a pointer of an object, right? So we're going to point to the function get name. And if we were to do that, we shouldn't have any issues here. Although we're not really using it, so it might yell at us that... No, it's not going to yell at us that it's not being used. But we're at least getting it. Now, you might decide, well, let's test this, make sure it's working. Let's print it out for us. So let's do output. Of course, surround this in our parentheses. Output, self, and get name. Do a quick 2-second rebuild. Oh, and you saw we had a bunch of errors down there. And we're not getting anything printed out. Well, if we take a look, we have a lot of errors. And that's because this isn't how we actually have to wrap self get name into another function to do this, as he cannot convert argument 1 from string name. So what we actually need to do is we need to wrap this in a get c string. Right. So we have output, open parentheses, get c string, open parentheses, self pointing get name, open and close parentheses, and then 2 more close, followed by our semicolon. Now, if we go to rebuild this, you see all those errors disappear. And if we run this, our name is now actually going to get printed out because now it's a properly formatted string for us, or a proper string that we can use inside of output. And you see it's just printing main in this case, but if I were to go ahead and rename this node, say main scene node, right? Save that scene. If we go to run it, what do we got? We have the update, main scene node. So you see it is printing out the name of that node. Now, what if we want to do set or get a node and set the value of something? So in our case, we're going to start with the label because we want to set that label to 0 when we start. So because we want to work with a label, we need to go up top. We're going to add a new include. This is our Godot /classes/label.hpp. I can move back down to my on ready, and we need to go ahead and get this node. So we're going to do auto. Let's call it let's say my label equals get node, and this is where we have to do our carets, open and close, pass in the type that it is, which is a label, open and close parentheses, end it with a semicolon. Inside of these parentheses is a string of the path. First, this is going to be main scene node /GUI/label. Right, and that's what allows us to get access to that, access to our label. So now the our my label here should now be accessed, or we should now be able to access this. And for this, we'll do my label. And remember, this is pointing towards our node. So we're going to use the point, set, text, and whatever string we want to pass in here. Which for us is going to be a 0. If we run that, I'm not going to get anything because I do have to hit rebuild real quick. 2 seconds. Now we can run it. Oh, We must have gotten an error that I skipped over. What do we got? Cannot open include file. Oh, I have a typo at the top. I said le bleu. You want a label, not a le bleu. Alright. Quick rebuild. That should fix that. Unless we have another issue. There we go. I just had a typo. I run it. And we can see now it's set to 0. Alright. Now, what else do we want? Maybe we want our horizontal alignment to be center. Maybe. It's just in the inspector though, so we can just go ahead and set that. No problem. And that's, of course, not going to affect anything for us. But there we go. Looks nicer. It's in the middle. Now for the button. We could go ahead and grab that. And we could do it the exact same way. Right, so let's go ahead and do the same and get our button. So we go up to the top, include Godot classes button HPP. And we can move on down. Here we go. On ready, and we'll do auto my button equals get node, and inside the carets button, and we pass in a path much like the one that we had with our label, main scene node slash GUI slash button. Make sure you typed it right. You can very easily be prone to typos. And if we rebuild real quick just to make sure, we should see no errors. If we run it, we should have no issues. We should have no crashes. Everything still runs perfectly fine. So now let's change the text on the button. So my button, point to set text. And we'll set this text to press me. Build so we can test real quick, run it, and there we go. We have our button that says press me, our label that says 0. So now we need our button to connect. We need our button to work. Well, if we go to our button, just like we would normally in the inspector, and go to node to get to our signals, we can look at press, double click it, copy that name of the receiver method, connect it to our node with the script. And we have void on button press because that was the name of my function. It has no arguments. So I drop to the next line and open our curly braces. So to test this out, let's go to output. And let's go ahead and print out press. So if this works, then every time we click this button, it should print out to our console pressed. Okay, so it's working perfectly fine. Excellent. So now what I'm going to do is I'm going to come up to our properties, and since we actually don't need any of this, I'm going to have just the one. It's not going to be running speed. It's going to be do we want to do it? No, we'll just do it by a defined amount. Okay, so every time we press it, we want to would it be easier? Actually, yeah, it would be easier. So we just have a property. We'll call this score. It's an integer, and it's going to start at 0. Right? So if we come down to on button pressed, instead of printing, what we can do is, so now we have our score identified at the top. What we can do is instead of doing pressed, we'll do %i because we have an integer, and we're going to print out the score. And obviously, if you're doing this normally, you don't have to stop and rebuild as much as we're doing here. We're just doing this for every step of the way. Make sure everything works because we're new, right? So we're taking a look and we see the score is getting printed out. It's always 0. We know that's working. So what we want to do now is what? We want to update that score. Well, we're going to increase that score by 1. Then all we have to do is do score plus plus. Of course, end it with a semicolon and save. do that quick rebuild and take a look. Now, every time we press that button, we're going to see the score increase by 1 and get printed out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. Now, of course, if you want this to increase by some other amounts, of course, you can do score plus 10, right? Do that rebuild, take a look, and you're going to go up 10. Oh, we're only going to go zeros. Well, that's unfortunate there. And that's because, of course, we're not setting it. So it'll be score, right? And just as you see, and it continues to go. So however way you want to go about that, obviously I'm just going to do plus plus because we only need it to go up by 1. And instead of the output, we need to get our label and set its text. So of course it's going to be, we're going to do auto, grab our label, set text. Instead of 0, it's going to be %i for our integer. And we can pass in score. And let's take a look what happens then. Oh, I saw it. We had an error. Now what was our error? Term does not evaluate to a function, taking 1 argument. That is on line 51. Okay, yep. So that was right there. And you know what? That makes sense. I'm a little stupid. We're just passing in score, obviously, because that's what we're setting text to. That's my fault, being a little dummy, thinking about output. So now you might look at this and see a lot of red. You might be scared. But all it's really telling us is our score is an int, and this function is taking a string. So we need to convert that integer into a string. And there's a few ways we can do that. Right? We could come in and we could do string : num int 64 and wrap our score in that. And if we build that, we're going to see that works perfectly fine. No errors. And if we run it, our label is going to update with our numbers. Perfect, right? Now, there's a much shorter option that we have, and that is this itos and wrap it around score. And I'll go ahead and rebuild it, and you'll see again, no errors. And if we run it, it's going to work exactly the same. So itos, much shorter of an option for us. But there we go. Now we have our little game. We click it, and it updates our label text. Every time we click our button, and the signal is received. All right. So there you go. There's a small little intro there, where everything that we're doing, we're looking at the includes, where we've looked at setting properties of different types, as well as the hints and the strings, hint strings, how to create the enums with the drop downs. I've shown you how to get self, shown you how to get nodes, how to use your functions on those nodes, right? Like set text. Right, so we're setting properties, getting nodes. We've connected a signal, and we've performed actions related to the signal. We've modified a previously defined property of ours, previously defined variable, and we've converted that variable from an int into a string to be used for setting the text for a label. That was a lot. Hopefully it wasn't too confusing, and hopefully that gives you a decent introduction to starting with using C++ here. I already know this is going to be a pretty long video. It's probably, I see the time there, but obviously I'm cutting pieces out, probably like 40 minutes to get you started. All right, take care, have yourselves a good one, and I'll see you guys next time.